Hello everyone, this is PM Chalamani here. Today we are going to explore the Lagrange's linear equation in multipliers method. Okay, so I will explain what is multipliers method through an example. Here we have an example. It is solve x is multiplying with z square minus y square p plus y is multiplying with x square minus z square q is equal to z is multiplying with y square minus z square. So this is the problem which we are going to solve today. Okay. So first step is we have to determine whether the given problem is following Lagrange's linear equation pattern or not. So this is the first step. So first, what is Lagrange's linear equation pattern? So this is the Lagrange's linear equation pattern. So here we have capital P small p plus capital Q small q, which is equal to R, right? So let us come to question. So we have small p, here we have small q. So on the right hand side we have some expression. So the coefficient part of small p is going to be capital P. Similarly, the coefficient of small q is going to be capital Q. So obviously what we have in the right hand side is going to be capital R. So now we know what is capital P and what is capital Q and what is capital R. So that is we have to write in the next step. So our capital P is this part. I just have written here. Similarly, what is capital Q and what is capital R, which we are obtaining from the question itself, right? So after identifying all these three results, let's come to step 2. In step 2, we have to write what is the auxiliary equation. So the auxiliary equation is going to give us the general solution, right? So this is the general formula for auxiliary equation in Lagrange's linear equation, right? So it is dx by t is equal to dy by q is equal to dz by r, right? Okay. Now from this auxiliary equation, what we have to observe, what is p and what is q and what is r, which we have already got it here, right? So now I am going to substitute these three results in this auxiliary equation. Let us see what happened, right? So this is this auxiliary equation becomes, after substituting these three results, dx is divided by under its value and dy is divided by under its q value. Similarly, dz is divided by under its actual value of r, right? So after writing all these three results, from this is your current auxiliary equation. Here what you have to do? You have to, okay, you have to obtain the general solution from this auxiliary equation by using some mathematical concepts. So there are two ways to solve this auxiliary equation to obtain the general solution. The first way is grouping method. The second way is multiplier method. So we have discussed what is grouping method and how to solve the problems by using grouping methods in previous video. So in this video, we are going to use multiplier method. So before we are going to use multiplier method, first we should know why we have to use multiplier method and when we can use the grouping method. So let us see. Let us see here. So here I'm just separating the variables. If variables are separated into different parts, then you can use a grouping method. If you cannot separate the variable, you can't use the grouping method. Where instead of using grouping method, you have to use you have to use the multipliers method, right? So here I'm just checking whether the variables got separated or not. So dx is divided by x. Still we are having z and y in the x variable, right? So similarly, in the y derivative, we are having in terms of x and z also. In the z derivative, we have x and y variable also. So the variables are not separated and you cannot separate the variables, which means that here you should have only dx by x, or in terms of x, dy, which means in terms of y only you should have. Okay, if you have so, you can use a grouping method. Okay, if you do not have so, then you can go with multiplier method. Let's come to multiplier method in step 3. There are two multipliers that you have to figure out for this problem, right? So your multiplier should give the answer is equal to 0 when I add the denominator. Okay, so I repeat, when I add the denominator, I should get 0. Okay, so that is in this way you have to choose your multiplier. So in some cases it may directly get is equal to 0 when you add. So in that case, your multiplier is 1, right? So in some cases, it will not get is equal to 0 directly when you add the denominator. So in that case, you have to add, or you have to multiply, or you have to divide whatever you want, that has to make the denominator is equal to 0, right? So I'm just checking whether my denominator is getting 0 when I add directly or not. So it is x z square x into y square. So is there any other x z square? There is no x z square. We have x square z, right? So here we need one more z in order to get 0. So in this aspect, I'm just thinking. So let's come here. So if I multiply x, y, z on both sides, then let us see what happens. So when I multiply x in the numerator, then it becomes x into dx. So when I multiply x in the denominator, because whatever we are doing as mathematically, we have to do in both numerator and the denominator, right? So now when you multiply an x in the denominator, it becomes x square. Similarly, y is divided by y square and z is divided by z square, because we are choosing x, y, z as multiplier. So now let us check whether we are getting 0 or not, right? So in this case, x square z square. So here we have x minus x square and z square when we multiply. So now I'm just writing all these results by adding. So it is x into dx plus y into dy plus z into dz. Let's come to denominator. This is the important part here. So in the denominator, we have to cancel all the terms that has to meet the value 0, right? So when we are checking, so it is cancelling all the values. So the denominator is 0. There is a formula. If your denominator is 0, then your numerator is also equal to 0, right? Here, you may get doubt like, suppose if anything is divided by 0 is equal to infinity. So, okay, this is the common doubt that everybody can have. So, you should not apply that rule here. Okay, instead of applying this rule here, what you have to do, you have to apply the multipliers rule here. What is saying in the multipliers rule? It is saying if you are getting 0 in the denomination, then your numerator value is equal to 0. That I have written here, because we are getting 0 in the denomination, right? So if we are getting 0 in the denomination, then numerator is equal to 0. Once you get this step, then everything is easy. So whatever you have followed in the grouping method, that you have to follow here also, right? So what we have followed in grouping method from this step, we have followed the integrating. So same situation we are going to follow here. So I'm going to integrate on both sides. So after integrating, I get this one. To integrate this, you can use this formula. The formula is x power n into dx, which is equal to x power n plus 1 is divided by n plus 1. So you can use this formula to integrate. I just have used this formula to all these three steps. Okay. After integrating, I get this one is my answer. So the on right hand side you will get constant. So this is my first solution. Your first constant value is going to be your first solution. Similarly, you should find out what is the second solution, right? So in step 3, we have chosen one multiplier. By applying that multiplier, we have got the first solution. The same way we are going to use in fourth step. So we have to choose another multiplier, okay? But by applying the same concept with the help of this multiplier, you will get another solution. So remember, here what you have to understand, there are n number of multipliers for each problem. You can use any multiplier which should satisfy the condition, okay? So here I'm going to choose another multiplier. So this time already I have used x, y, z. So if you use that same multiplier here, then you will get the same answer. So that you should not do. So what you have to do, you have to find out another multiplier. So this time I'm just checking what another value is going to make this denomination is 0. So if I cancel this x, y and z, then when you add the bracket term, it will be 0. Okay. So to cancel this x, y, z, what I have to do? I have to divide this x, y, z. So on both numerator and denominator. So after dividing x, it becomes dx by x is divided by x is divided by x. This x will be cancelled, right? So similarly here y will be cancelled, here z will be cancelled, and you will have dy by y and dz by z in the only in the numerator. So that I have written here, right? So after writing the steps, we are going to add numerator and denominator. So when we are adding numerator and denominator, what we have to get? We have to get in the denomination is equal to 0, right? So we are checking whether we are getting 0 or not. So I'm just adding z square, y square, x square, z square, y square, z square. So all the values are getting 0. So if denomination is 0, then what is saying in the rule? You can equate the numerator value is equal to 0, right? I just have equated the numerator value is equal to 0. Okay, so here the same situation, the same thing. We have to integrate, right? So to integrate, use the integration formula. First use the integration symbol, okay? Then dx by x, if you integrate, what is the answer? It is log x. Similarly, log y plus log z. On the right hand side, you will get your function also in terms of log. So it is log c2. So by using log property, addition can be written as multiplication. Okay. So now you can take exponential on both sides. Log will be removed. The answer is xyz is equal to c2, right? So this is my second solution. Let's come to the general solution formula. It is pi of u comma v. U is nothing but your constant one. First one c1 and c2. C1 is your u and c2 is your v. So you know both c1 and c2. Your job is you have to substitute what is C1 and what is C2 in this general formula. So I just have substitute both results, that is equal to 0. So this is my general solution, right? So students, this is very important in engineering. So any one problem in this type definitely will be asked in the semester examination. So I hope this problem will make you understand clearly. So if you have any doubt on this topic, you can comment me in the comment box. Thank you. I will meet you next video.